So our last section in this chapter is going to be about applications. So we're really just going to be utilizing right triangles and different terminology that we've had to solve different problems. So the first example we're going to start at is we're going to solve this right triangle. So we have our right angle here, and then we have this other angle, and I want to figure out what side A, side B, and this remaining angle B are. So unfortunately, this one is given in terms of those minutes and seconds, but just minutes. We don't have seconds, thankfully. So if I want to start by finding out angle B, well, I know that it's going to be complementary with angle A. So if I look at angle A plus angle B, it's got to equal 90 degrees. So angle B is going to be 90 degrees minus 42 degrees and 33 minutes. Well, if I want to be able to subtract these, it's going to make a lot more sense if I give this some minutes so I can subtract like things. So 90 degrees is the same thing as 89 degrees and 60 minutes. So if I take 89 degrees and 60 minutes, and I subtract 42 degrees and 33 minutes, then I just subtract the like things. 89 minus 42 is going to give me 47. So I'm left with 47 degrees. 60 minus 33 gives me 27. So 90 degrees minus 40 degrees and 33 minutes is 47 degrees and 27 minutes. So that is our missing angle. So angle B in here, 47 degrees, 27 minutes. To be able to figure out these other two, I'm going to have to evaluate sine of different angles. So I am going to put the 42 degrees, 33 minutes in decimal form. So if I look at this angle, this is 42 degrees, and then that's really 33 out of 60 degrees. So I am going to need a calculator to be able to do this. So I'm going to bring up Desmos. If you're using a handheld calculator, make sure your mode is correct. There should be a DEG button and then an RAD. DEG is going to stand for degrees. RAD means your angles in radians. Okay, so I've got Desmos up here. Again, you'll see these two buttons, radians, degrees. We're going to be working with degrees. First thing I'm going to do though is go ahead and figure out what this is. So if I take 33 and I divide it by 60, that gives me 0.55. So adding that to 42 gives me 42.55 degrees. Okay, so that's much easier to work with because I don't have buttons for minutes or seconds or anything like that on here. Now we'll start by trying to figure out what side A is. And I always like to use the information that's given to me, not the ones I calculated. It wouldn't be a problem here, but if you have to round, using a rounded answer to then get something else can make your rounding compound, and that's a little bit annoying. So I want to relate side A with this angle A. And then the only other side I know right now is the hypotenuse, 969. So if I think about those three connections, I have the angle, the side opposite of it, and the hypotenuse. So if I take sine of angle A, it's going to be the opposite side over the hypotenuse. Well, angle A I know, so I can go ahead and I can solve for side A by just multiplying by 969. So that would make these two disappear. So I'm going to take 969 and times that by sine of 42.55 degrees. And this gives me our unknown side A. So now I can go ahead and plug this in my calculator. We're gonna go clear all. I've got 969. I'm gonna go to the functions tab to get my sine function. And again, I wanna make sure I'm in degrees, and we're gonna do 42.55. So in this case, your directions will tell you what you need to round to, but I'm gonna round to the nearest integer here. So this would be 655, and then my units are the same as my units here, which is meters. So that is side A, okay? Now I wanna figure out what side B is, and again, I wanna use this angle and the 969. So side B is going to be adjacent to the given angle. So if I look at cosine of angle A, that's equal to B over 969. So solving for B, we go ahead and multiply by 969. That makes these two cancel out. So 969 times cosine of 42.55 degrees will be side B. So we're gonna go ahead and plug that in our calculator, 969, go to the cosine function of 42.55 degrees, gives us side B is around 714 when rounded to the nearest integer. And then my units are meters. Okay. So those are the two different sides, and then we figured out our third angle as well. So this is every component of our triangle, okay? So I no longer need my calculator for at least this next problem. We're gonna go ahead and we're gonna find the measure of each angle. So essentially we're looking at what is this angle here and what is this angle here. Well, since they form a straight line, if I add these two angles together, it better equal 180 degrees. So I can solve for x. 7x plus 11x gives me 18x is equal to 180. So getting x on its own, dividing by 18, we thankfully don't necessarily need a calculator for that. X itself is representing 10 degrees. So when I want the measure of each of these angles, the one angle is 7x. So it'd be 7 times 10 or 70 degrees. The other angle is 11x. So if you do 11 times 10, it gives you 110 degrees. So this angle here is 110, and this angle would be 70, okay? All right, so I really only have one more problem left because again, a lot of them are just going to be about solving right triangles. This one's definitely the most complicated and it's gonna deal with bearings. So if you're at sea, if you're on a plane, they use bearings to kind of indicate where you're flying. And then you also have ships, they deal with nautical knots and stuff like that. So this one tells us the bearing from A to C is southeast 53 degrees. So you start out south, you're heading in the east direction as well, and it's at an angle of 53 degrees. The bearing from A to B is northeast 83, and then from B to C is southwest 37 degrees. A plane flying at 250 miles per hour takes 3.2 hours to go from A to B. We ultimately want to find the distance from A to C. Okay. So there is a lot going on here. So what I'm going to do is I'm going to condense this information. Going from A to C is going to be southeast 53 degrees. From A to B is northeast 83 degrees. And then from B to C is going to be southwest 37 degrees. So ultimately this is going to create a triangle, and these angles are going to fill in somewhere. That's the hardest part with this, so we're going to spend the time with it. So if here's our starting point at A, you can imagine that there is a straight line going through A. To get to point C, I'm going to head southeast at an angle of 53 degrees. So I go southeast 53 degrees. So that would be this angle here. So my point C is going to land somewhere around here. And this angle is going to be 53 degrees. To go to A to B, I need to go northeast 83. So northeast 83 degrees. So this angle here would be 83. Okay. We are working with right triangles, so it's likely that this is going to end up being a right triangle, but just a spoiler alert. But again, this angle here would be 83 degrees because you go northeast at an angle of 83. Then to go from B to C, which is right here, again, I'm going to put a straight line in that's parallel through all of these to just help me out visually. To go from B to C, we go southwest 37 degrees. So this angle here will be 37. Okay. And what I want to do is I want to figure out what is the distance from A to C. So ultimately, I'm looking for this side length here. When we label triangles, we usually label the angle opposite that letter. So if this is angle A, the side opposite of it would be side A. This is angle B, so the side opposite of it will be little b. And then C gets confusing because capital C and little c look identical, but that is little c here, okay? So I need to ultimately figure out what is B equal to. I want the distance from A to C. So I don't care what this is, but I'm probably going to need one of these two sides to figure this out, okay? First thing I'm going to do is I'm going to try to see, can I figure out any of the angles within here? This one's not too terrible because I know these three have to add up to 180. So if I call this angle alpha here, alpha is from a line, we're removing the 83 and the 53 we already have placed. So this angle would be 44 degrees if you subtract that. Now, I can figure out this angle here, but I can't figure out this one to begin with. So I'm going to see, maybe can I figure out what this has to be? Okay. Well, these bearings are basically, if you were to draw these parallel lines, this is a transversal that's cut through it. So if this is 53 degrees, it's going to make this part 53 degrees as well. So from here to here is 53. And then likewise, these are two parallel lines cut by that transversal. So this bearing being 37 means this bearing is 37 degrees as well. Well, if you take 53 and add 37 to it, this ends up forming a right angle in total, which is fantastic because now I have a right triangle. So if I want to find side C or side B, I know this angle. I need one of these sides to be able to use my trig functions, okay? Well, there's a piece of information we haven't used yet. A plane flew 250 miles per hour from A to B, and it took them 3.2 hours to get there. So we can actually utilize that to find the hypotenuse, okay? So we can find side C since the plane took 3.2 hours to travel that distance at 250 miles per hour. So they flew 250 miles per hour for 3.2 hours. Side C is then just found by multiplying the two. So 3.2 times 250 gives you 800. So side C is 800 miles. Okay. So what I'm going to do is I'm really just going to take this triangle and I'm now going to turn it in a better way so we can actually go through our calculations. We've got our right triangle. Here's our right angle with C. This is A. This is B. This side is 800 miles, which is C. This angle is alpha, which is 44. And my goal is to figure out what does B equal. So I've got the angle 44, I've got the side adjacent, and I have the hypotenuse. So if I look at cosine of 44 degrees, that is the adjacent over the hypotenuse. So to find B, just go ahead and multiply both sides by 800. So B is going to equal 800 times cosine of 44 degrees. So I'm going to trust you can now plug this into your calculator, make sure you're in degree mode, but side B should give you 575.47 miles. So give these a shot. Word problems are definitely difficult. I understand that.